Hey everybody. In our last lesson, we were comparing means between two groups. So, for instance, where we left off, we were looking at the length of stay of patients in the hospital between those that had a spouse and those that did not. But what you probably noticed was that t-tests, or maybe we referred to it, really can only occur when your categorical variable has only two groups. And so it's very limiting. So, for instance, when we have a variable that has three or more groups, like marital, and we'll do a table of marital right here just um, to demonstrate this. We have four groups in the marital category. So if we were going to look at length of stay in the hospital between, comparing each of these groups, we would have to do multiple t-tests. So for instance, we'd have to do a t-test comparing the people in the single group to the married group, the single with the married patients, the single with the divorced patients, the married with the widowed patients, the married with the divorced patients, and then the widowed patients to the divorced patients. And so that's an awful lot of t-tests. And remember, every time we do a statistical test, we're testing our chances of making a type 1 error. And we assume that if our chances of making a type 1 error are 5% or less, we can reject the null hypothesis and accept our hypothesis that there are somehow differences between these groups and that they come from different populations. However, a 5% chance of being wrong means there is still a chance that we are wrong. And so to do multiple t-tests, every time we do that t-test, we will, in an additional t-test, we will increase the chances that we are making that type 1 error. That is, we observe differences and assume there are differences in the population when in fact they are not. So t-tests cause a lot of problems when you have too many groups, meaning more than two. So the solution is to do a comparison, an analysis of variance that takes into account the multiple comparisons between groups. And that is what we are going to demonstrate today. Now, we are still comparing means. However, we're going to look at the means across multiple groups. And so we will start with the idea of marital. So to demonstrate this, we are going to almost replicate what we had previously. We're going to look at the, whoops, I need to put my hashtag. Look at the relationship. Oops, I want to, yeah, we just did this up here. Between a continuous variable and a categorical, I'm going to go to the next line, variable with three or more groups. Again, anytime you have more than two groups, we'll want to do that. And we're going to repeat very much what we had done previously. We're going to start with our describe by. We'll do our group box plots, but then we will move on to something a little bit more sophisticated, that one-way analysis of variance. So we're just extending what we had done previously. And to demonstrate this, we're going to look at marital status, as I just showed you in that table, with patient's length of stay. So we're going to do, now again, we need to remember to have the psych package required. And I believe it's required from last time, but we will just double check that by scrolling down. And we do. Okay. So we're going to type describe by, and we're going to do length of stay, comma, marital. Oops. Describe by. And I'm going to even make a note saying, oops, put continuous variable first. I'm just making this, it should be a smaller window for you. I just made this bigger so you all could see this. Okay, now we're going to run this, and we can take a look at the length of stay. For the 16 single patients, the average length of stay was 39 days with a median of 40. So in this case, our median and mean are pretty close together. The standard deviation is pretty high. It's 24.6 days. The married folks are our largest group with 95 patients, and they seem to have the shortest length of stay with only 12.23 days, standard deviation 11.75. And notice the median is more than 4 days less than the mean in that group. So the variation that we're going to see probably between these groups is going to be pretty interesting when we do our group box plot. Now the widowed folks had a length of stay of 17.61 days with a fairly high standard deviation of 16.45. But notice the median, again, that middle value is 5 days less than the mean. And the divorce group only has 4 patients in it. And they had a length of stay of 29.5 days. But the standard deviation, there was a lot of variation within these 4 patients, an average of 33.07 days. So the median may be a better representation of the divorced folks, and that's a 16.5 day median. So let's start by looking at our group box plot. And what I'm going to do, and I suggest you do the same thing when you're copying, when you are replicating code that's similar. We could just go, we could just put length of stay in marital, but I want to just group everything together for this analysis. So I'm just going to copy this and we'll paste it here. So when you know you're going to do a one-way analysis of variance, you'll have just all the code grouped together. So I'm going to keep length of stay and marital, change it to marital. And we're going to do length of stay by marital status. And if we go across, we will have patients, we'll just put in marital status. And length of stay in days. Now, we're going to have 4 box plots next to each other, so we're going to want to make sure when we run this that we have sort of plenty of space here. So, you can adjust your window accordingly. Okay, so we'll try this and we'll see how it looks. Let's do a run. And yeah, we see, as I had mentioned before, based on my experience, we see, there's a lot of variation here. This is the smallest height of the box, so that middle 50% of the data is more closely held together, closer together than the divorced folks, where we see the most variation. But we see a lot of outliers in the married folks. And the single folks, if you just look at the medians, have the longest length of stay. And that's not completely clear why. You would think that somebody that has somebody living with them may have a shorter length of stay, because if their activities of daily living are not as strong, they could get some help. So that sort of explains why the married folks are lower, but it doesn't explain the widowed or the divorced folks. But notice that our grouped box plot has each group separate, and each group is labeled accordingly. If we had, I want to just demonstrate this to you. I don't know how it'll look now. We'll put it real small. If we made it real small, you would see that these labels wouldn't all be here. You need to make sure that all your all your groups are displayed. So you'll want to adjust the size of your window. And notice that I can do that dynamically. I can just drag it until it looks good, and then I can export it. So the next step is to do our one-way analysis of variance. So the first thing we want to do is create a vector. And I'm going to pull this here so you can see this vector will be placed into our values eventually. So we're going to call this Um, we'll call it marital XLOS, marital by length of stay. And we're going to create that vector by using the less than sign and the dash. That's that arrow that we're creating. I'm going to make this look here. And then the function to do the analysis of variance is AOV. And then what we are going to do is put in our continuous variable first, so LOS, and then we're going to do it by. So the idea of that by is that tilde that we discussed last week in between the length of stay and our grouping variable, and then we'll put in our grouping variable. And oops, we'll just put that there. And I don't know why we have an X here. We're going to run that and we'll see how that works. And when we do that, our little X goes away. And we'll see we now have this vector in here that has a lot of stuff. So we want to see what's in that analysis of variance. And the first thing we're going to do is do summary. And we have to put this vector that we created in the parentheses. So we'll go marital X, and of course as you type you'll get completion, and we'll put that in. And now we'll see the results of that one-way analysis of variance. And here we see that the chances of making a type 1 error are really low. In fact, it's so low that the results are written, this is our p-value, in scientific notation. So this is 1.74 times 10 to the negative 8. So if I was going to write that out, I'll write that out here in the console. We would have 7 zeros, 1, 2, 3, 4, 5, 6, 7, and then 174. That's our actual p-value. So we also see that we have this code here, these 3 stars. And if we look at the significance code, it means that our significance level is somewhere between 0.001 and 0. Now, the chance of making a type 1 error is never actually 0, because anything could happen, but it's so low that it's rounded to 0. So there are significant differences between the groups. But what this analysis of variance does not tell us is where those significant differences lie. So for instance, are the divorced folks statistically different from the single folks? Are the single folks different than the married folks? Or what? There can be differences between some of the groups, but not all the groups. And so we're going to do a post hoc test that does additional statistical analysis to tell us where those differences lie. So the command for that, and this is in page 153 of the Making Your Case book, is Tukey. Oops, I don't know why we're here. We'll put it up here and enter. Tukey HSD. That's the command for the post hoc test. And in the parentheses, we're going to put that same vector, marital, by length of stay in there. And hopefully we will see where these differences lie. Okay, now this is an adjusted p-value. That's why it says adjusted, because it takes into account the multiple comparisons that we talked about before. So this is where we compare the married folks to the single folks, the married folks to the widowed folks, the married folks to the divorced folks. And of course, now we have every single comparison that we identified previously. And so we're going to go with that 0.05 threshold again. So we see that the married folks are significantly different than the single folks. And this is the difference in length of stay. So this is a 26.78 difference length of stay. That means the married folks on average are staying nearly 27 days less than the single folks. And the other significant difference is between the widowed folks and the single folks. So the single folks have a longer length of stay than the widowed folks by about 21 days. These other differences that are not statistically significant, we just can't make any statistical inference, probably because the sample sizes are too small. Understand that remember we only had 4 people in our divorced group, and it would be hard to make generalizations about a population based on only 4 observations. And it may be that the married folks, let's see how many people were in our married group. We had a lot of people in there, but the differences in the means may not be large enough to be able to reject the null hypothesis. So remember, the null hypothesis is that there's no significant differences between these groups. And so even though we observe differences between, say, the divorced and the single folks, we can't reject that null hypothesis that there are significant differences there. But overall, it appears that marital status is related to length of stay. So that's one demonstration. I'm going to do one more demonstration for you, and that's having to do with the age category and activities of daily living. Because what we could hypothesize, and we haven't looked too much at this yet, is that activities of daily living could be related to people's length of stay. We looked a little bit. So this variable TCAT sum, like I said, is the sum of those initial TCATS variables that are described in your text. So let's take a look at whether age is related. That age cat variable is related to that TCAT sum. So we're going to take this script, and again, I'm showing you this for demonstration purposes. We'll put TCAT sum here and age cat. And let's just look at the age categories and people's activities of daily living. Now remember, the higher scores are related to more independence of patients. So our first category are those in the 65 to 69-year-old group. There's 41 patients in that group. And notice that their activities of daily living, on average, is higher than for any of the other groups. In fact, you see a general decline in the averages over time. However, the medians tell us a different story. It looks like, in terms of medians, every group looks the same except for those that are 80 and older. So let's take a look and look at group box plots to see if that helps us at all. And so we'll put TCAT sum here and age cat, and we'll need to change this. So we will say activities of daily living. So we'll do ADL score by age group. We'll call this age group. And we'll have our age groups on our x-axis. And we will have our ADL scores on our y-axis. And we will run it. And again, you see that the top of the box, for the 65 to 69, you see the box is that one line. There's very little variation except for these outliers that have lower scores. So these folks are more dependent. But here you see the medians across these 3 groups being the same. And you also see, as the age groups get older, there's more variation in activity of daily living score. So this sort of makes sense. It's not terribly surprising. So let's take a look. Let's create a vector, and we'll call it age by ADL. And we will have TCAT sum by age cat. Now, just so you know, if you don't have statistically significant differences between the groups, there really is no reason to do that Tukey test. you won't find anything. So it's really dependent upon the results of the overall analysis of variance. So we'll run these two first, and then we'll see what we get. So now we've run it. We don't have anything in the console, but we see our age by ADL up in our global environment. And oops, that would have not worked out well. We need to put the age by ADL here. And we'll run that. And again, we know it's statistically significant because we have some of these stars. So it's 0.0119. Now it's not as low as it was before, but it's well below that 0.05 threshold. And again, the significance code correctly indicates that the actual chance of making a type 1 error, which is 1.19%, is somewhere between 0.01 and 0.05. So this again is statistically significant. So now we will do the Tukey test, and we will see if we now, once in a while, by the way, you will do a Tukey test and not find differences between any of the groups specifically, but an overall difference. So we'll see what we have here. We see one. It's between the 80 and older group and the 65 to 69-year-olds. So you see that here. And on average, the ADL scores are lower in the 80 and older group by 2.6 days. And you, by the way, you could do that calculation yourself, but you obviously don't need to do that. That if you took this 16.76 and subtracted 14.15, that's where they get this minus 2.60. So for your homework, I'm going to have you do this type of analysis to test the hypothesis that age category here is related to length of stay. So let's see what you all find, and I hope you've found this lesson helpful.